I am Dr. Chandran and it is my great pleasure to extend a warm welcome to our esteemed speaker, Dr. Ajila Chandran Matheyambath, as well as to my colleagues and all the participants joining us today. Dr. Ajila Madam holds a PhD in biotechnology from the Central Food Technological Research Institute, Mysore city in India. She has made remarkable contribution to academia and research with over 15 years of teaching experiences spanning biotechnology, molecular biology, microbiology, environmental science, food science, biochemistry, and analytical chemistry. Her expertise has been shared across prestigious institutions and universities in Canada, Australia, US, and India also. Currently, Madam serves as an assistant professor in the Department of Chemistry and Forensic Science at the College of Science, Technology, Engineering, and Mathematics, Eastern Kentucky University, USA. Dr. Ajila Madam's research has been widely recognized in international journal with number of published research articles, 7 book chapters, and 4 patents to her credit. We are honored to have her with us today, and I look forward to an insightful session. Thank you.
Hi, good evening, everyone, and thank you so much
Good evening,
for
ma'am.
Dr.
Good evening.
Yeah, thank you so much, Dr. Dilesh Dumore, for the detailed elaboration and introduction about me. And I'm so excited to be here today and to share the knowledge between us. Okay, let me share my now. Just a moment. Yeah. Okay. Okay. Are you able to see my slides?
Yes, ma'am.
Thank you so much.
Yes,
So let's start, or should we wait? Should we wait for more people? Because I see that still people are coming. So should we wait for them, or let's?
yeah, sure, ma'am. We'll take 1 or 2 minutes.
Okay, great. Okay, so we'll wait for them. Yeah.
Ma'am, let we start the
Okay.
session.
Okay. Okay. Yeah. So, yeah. Good evening, everyone. Once again, and I'm Dr. Ajila Chandran Matheyambath, and currently I'm an assistant professor in Department of Chemistry and Forensic Science at College of Stone in Eastern Kentucky University. And yeah, thank you very much for inviting me for this great event, the faculty development program, especially on green chemistry, which is one of the thriving areas in science nowadays, right? Like everybody goes behind environmental sustainability, everything. So it's one of the thriving science area. So my topic, which I'm going to discuss today, is on insights on green chemistry and food processing systems with its sustainable solutions for a green future. Okay, so the outline of my talk will be explained like this. First, we'll see what is green, like the introduction and what is the importance of green chemistry, and then we come to what is green chemistry, and we'll see the role of green chemistry in food processing, and then we'll see some examples starting with my research, my previous research, and we'll see some roles on green chemistry and nutraceuticals, and then we'll see the barriers and challenges and future direction in green chemistry. So we know that environmental sustainability is an important factor nowadays. Like everywhere, we talk about that a lot, right? So the sustainability. So that is it's really important in the current world in terms of environment or the social impact or economics and in every sides in our life. So sustainable development is an evolving process that improves the economy, the environment, and society for the benefit of current and future generations. So how we can attain the sustainability, especially in terms of chemistry? So either can we use by latest technologies or good development chemistry. So there are different ways to attain this sustainability. So here in my talk, I'll be giving more importance on green chemistry and how that help us to attain the environment sustainability. Okay. So before going more directly going into the green chemistry, let us see about the current scenario now. Like we know that in our normal day-to-day life, we use a lot of products, right? Which is a lot of chemical products, especially. So here are some, sorry, this is coming a lot. Okay, here are some words that are used to describe the products we buy and use, right? Like the chemicals or when we buy or use any chemicals, like or any in products in the market, like whether it is from food or like anything like cosmetics or whatever we get in the market. Actually, we can't name it, right? So when we buy these products, we usually give some specific term for that, or we look for some specific term when we buy a product, right? Like either it can be chemical or green, synthetic, made, homemade, or engineered, chemical free, sustainable, preservative, recycled, modified, or it contains pesticide. If it's food, we ask whether it contains pesticide, or we'll look for whether it's a natural, organic, etc., etc. So what people generally like to hear about their products, like when you use a product, what type of products we'll be giving, like, oh, that will be good, how we like to hear about their products. So usually when we say that, like in the current trend, we know that like we goes everything for natural, right? So we look for a product, whether it's natural, is it organic, or it's a green chemical, or it's a sustainable or homemade, chemical free, or recycled. So most of the consumers, like we are, like as a whole, we are happy with the natural product, right? So when we say that like it's a chemical product or it's a synthetic or engineered or modified, even in a lot of engineered like modified food products we are using now, like genetically modified food products, GMO and all. And so this chemical word, it makes always, like people doesn't like much compared to the natural products. So that's why, like, for the sustainability development, we always go for a natural ways. Like that means avoiding the use of too much chemicals, or try to reduce the use of chemicals, because we know some process like food processing or whatever, we need to have chemicals, right? But here, in a way to attain the sustainability, the current we are like in the industries and all, we are trying to reduce the use of chemicals. So that is why the term towards, like, the more liking towards the natural term is increasing nowadays. The awareness towards that natural terms is increasing. Okay. So why? Because we know that, like, the importance of the chemicals, how they are affecting our health, environment, etc. So here comes the word green chemistry. Okay, so we would have heard about this green chemistry a lot, right? So what is green chemistry? So it's the initiative of green chemistry that is increasingly developed in 1990s. Um, so the green chemistry is the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substance like chemicals, which has many other side effects in our health and environment, in the design, manufacture, and application of a chemical or any food products we are using. So it is according to EPA, that is Environmental Protection Agency, green chemistry is defined as it's the design of a chemical. Sorry, design. Oh, okay, design or design of a chemical products and process that reduce or eliminate the use or generation of hazardous substance. So this the green chemistry, it applies across the life cycle of a chemical product like LCA, which includes its design, manufacture, use, and ultimate disposal. So it starts from the production to the processing, and then like the whole processing steps, and at the end, like if it is like how we have to dispose that product, right? Because when we dispose, it is again affecting the environment by creating pollutions, etc. So that's why we can say that this green chemistry, it is looking the all sustainable aspects. So that's why it's also known as sustainable chemistry. Oh, sorry, something is happening here, like a lot of messages coming. So so green chemistry is about innovation, understanding, and understanding its impacts, and many more. So basically, green chemistry that involves reducing. So reducing what? Reducing the waste and the materials that we are going to as like a starting materials, and reducing the hazard, and reducing the risk, like either health risk or environmental risk, and reducing the utilization of energy, so that will be more economical. And also it is a green chemistry try to reduce the environmental impact, and also very importantly, it's try to reduce the cost of the production or manufacture. So here, always when we talk about green chemistry, we get always connected with pollution, right? So always there will be a question whether green chemistry that is equal to cleaning up pollution. So is it something only connected with pollution? No, it is green chemistry means it is beginning from the starting process itself, or from the manufacturing process itself. So when we say cleaning, so let's see the difference between cleaning up pollution and green chemistry. So cleaning up pollution means it's also, we know the term, like maybe most of you must be very similar with the word that is remediation, right? So that involves the treating waste streams, like from the whole process, like whether it is a food industry or chemical industry, and of the pipe treatment, or clean up the environmental spills and other releases. So here we are in cleaning up pollution means we are actually we are at the end stage of the processing, like when the chemical or in the end product or the byproduct that is going into the environment, and that creating problems, and that pollution is cleaning up by different processes, or the process of remediation. But green chemistry means it is in the whole life cycle. As we said, green chemistry, it reduces the pollution at its source by minimizing or eliminating the hazards of chemical feedstocks, reagents, solvents, and products. So here, compared to the bioremediation, the green chemistry, it's reduces pollution not at the end. It is from its source itself by minimizing or eliminating the hazards of the chemical feedstocks, or whatever the chemical reagents we are using, or with the solvents we are using, and the final product, how it is going to impact the health and environment, and also the byproducts that is arised from the whole process. So we can say that cleaning up solution means that removes the hazardous materials from the environment, but green chemistry, the main difference is it keeps hazardous materials out of the environment in the first place. So from the beginning of the process itself, green chemistry try to reduce or keeping out from the hazardous materials. Okay, so let's say the some aspects of green chemistry. So the green chemistry means that is, as I told you, it is starting it's from the initial material itself, or starting material itself, and it goes through whole process. So for example, it is a like, different ways we can implement this green chemistry in any process, either by using controlling the catalysis process, or by solvent replacements. So nowadays, like, we try to use different solvents with the like, try to use very little solvent, or try to use a solvent which with the less impact on environment, and also use of renewable feedstocks. Like, we know that for any process, like, we need a source material, right, resource. So that can be like, we can use sometime, instead of synthetic medium or synthetic materials, we can use renewable feedstocks. And then we have to do the process optimization and process intensification, and then energy efficiency, implementing the energy efficient process and different separation process. I told you, where we use a lot of solvents, and safer reactions and reagents, and finally also waste minimization. So there are different aspects of green chemistry we need to take care when we are in a considering a process. Okay, so let's go more into green chemistry. So Paul Anstis is considered as the father of green chemistry, and he has done a lot of research on the green chemistry and how we can replace different chemicals with lesser impact on environment, and also like how we can reduce the whole chemical release from a process like that. And he's the one who with Paul Warner, they discovered the 12 principles, or they postulated the 12 principles of green chemistry. So the 12 principles of green chemistry involves, first is the first and foremost thing is prevent waste, and then second is maximize atom economy. That means, like, in a process, we know that, like, there is a design system, so that, like, there will be a contains a the initial material, and at the end there will be the products and byproducts, right? So maximizing the atom economy, they try to we can try to minimize minimize the byproducts, or like no items are left at the end. So we are like, it's a complete max or utilization of whole product. Like, we are converting the starting material completely to the end material by minimizing the end products. And third is less hazardous chemical synthesis. And so that is like safe, it's equal to safer chemicals and products, and then using safer solvents and reaction conditions, like optimized conditions, and then increase energy efficiency, and use renewable feedstocks, and avoid chemical derivatization, and use catalyst, and design chemicals and products for degradation, and analyze in real time to prevent pollution and minimize potential for accidents. So these 12 principles of green chemistry is considered as the basics of the green chemistry. So when we develop any methodology, any process based on green chemistry, we need to remember these 12 principles to implement into our process. So So like green chemistry, now we know that what is green chemistry and how we can implement these principles in our processing. So and also using this green chemistry has broad benefits, especially financially, in like economically. It lower the cost by fewer hazardous shipping costs and reduced waste disposal costs and reduced infrastructure cost and less time used to manage safety hazards. So what are the key principles of green chemistry? So as I told you, green chemistry is the design of chemical products and process which reduce or eliminate the use and generation of hazardous substance. How that can be done? But what are the key principles for that? So first and foremost, the prevention of waste, and then use of renewable resources and reduction in energy consumption and design for degradation. And so now let's see here, as I told you, we are looking the relation between green chemistry and food processing industry, right? So here, so let's see what is meant by food processing systems. So food processing, we know it's like it's something transforming, right? So the transformation of raw ingredients into consumable food products using different processes like a physical process or chemical or biological process. And we know that always like this conventional food processing systems, they can generate a lot of waste, and also there will be using different harmful chemicals, and also they are very energy intensive. So we know that implementing green chemistry in food processing system is a very important, or not only in providing a sustainable environment, like providing products with less health and environment impact. Also it is help us to reduce the energy utilization and also like more economic. So the importance of green chemistry in food processing, as I told you, it has basically three impacts. That is, first one is environmental impact. So the traditional food processing uses a lot of energy and water and produces a lot of waste, including chemicals that may harm the environment. And another concern, the foremost concern is health concerns. So here we know that in food processing we use different type of food additives, right? Conventional food additives, preservatives, and synthetic chemicals. They can pose risk to human health, and also in the economic impact or economic benefits. So by implementing this green chemistry in food processing, we can save the cost of uh, from the initial manufacture starting material itself. So the cost savings can be done through the use of sustainable practices and reduced waste. So now let's see the green chemistry principles in food processing. So I told you that like when we are implementing the green chemistry, we need to follow some principles. So how these green chemistry principles can be implemented in food processing, or what are the principles we can implement in food processing? First one is the substitution of harmful chemicals. So I told you that in food processing, different type of food preservatives or different type of synthetic chemicals are used. So these harmful chemicals can be substituted by different natural uh, compounds, like for example using natural preservatives like essential oils like rosemary, thyme. That's some examples. We know in India we use a lot of spices, right, which acts like a preservatives. So instead of using the synthetic one or chemical preservatives, and then replacing artificial colorants with the plant-based colors. We know like there are different food products with very beautiful colors. So if we could isolate or extract the colors from this natural resource, and that can be used in the food processing industry, it's an it is replacing the artificial colorant, so that we can minimize the chemical side effects, right? And then second thing is energy efficiency. So the principles can be implemented in utilizing this energy by developing low energy technologies like cold pressing and high pressure processing to replace heat intensive methods like in pasteurizations and all. So there are a lot of this type of energy technologies are trying for the food, different type of energy technologies are low energy technologies are implementing in the food processing industry nowadays. And the third and foremost important factor is a water conservation. So we know that water is a becoming a big issues in the world, right? So water recycling systems to minimize water wastage in food processing plants will have a great impact on the uh, on environmental sustainability and also economical viability. Using biodegradable packaging to reduce water intensive plastic production. So if we can use biodegradable packaging instead of the plastic materials we are using for the food packaging now, that can also help in the water conservation. So, so this is an simplified diagram of this how this where and all we can implement the green processing in food production and packaging. Is the same thing I have discussed now, like in the like food production and packaging. There are like by using sustainable agriculture or using sustainable food processing and preservation, and by reducing waste and valorization and green solvent and extraction methods, and food implementing in food packaging materials, and also analyzing the LCA and the sustainability analysis like more, so that we can implement the green process, green chemistry, and how we can minimize the the cost, like more cost effective. So we'll see some examples of this green chemistry applications in food processing. First example is biocatalysis. So we know that for the food processing we use lot of enzymes, right? Nowadays this the enzymes we are like it's produced by different ways. So nowadays a lot of research is happening by microbial fermentation system, so that it can be used. This fermentation system is microbial fermentation system is used for the production of enzymes. Okay, especially the use of enzymes for reactions such as fermentation and cheese production and the breakdown of fats for healthier oils. And another example is the use of supercritical carbon dioxide extraction methods. So here this is a green alternative to solvent-based extraction process that is used to obtain flavors, colors, and nutrients from plant materials. So implementing this method, we can reduce the use of solvents. And then food packaging innovations. A lot of innovations are happening in food packaging industries, especially the invention of many biodegradable and edible packaging materials that is derived from plant-based sources, and also development of packaging systems that extend shelf life without synthetic additives. So a lot of researches are going on in these areas, especially in biocatalysis and food packaging innovations. And an important thing, like we can implement this green process, green chemistry in food processing industry is by resource utilization. Okay, so I told you like this for the any food processing industry or any chemical industry, we are using lot of starting material, and then we need energy. So implementing this green principles in all these different aspects, so we can reduce the waste conservation, we can then, and energy efficiency. And this waste reduction mainly lie at the heart of green food processing initiatives, because we know that like there is a lot of waste are generated during the food processing, and that creates it's a big issue, right, in environmental pollution. So, and also implementing different techniques like ultrasound and pulsed electric fields, they can significantly lower energy consumption during processing. And also optimizing the process, whole process, like in different ways, either by using different solvents, lesser solvents, or using lesser water, or lesser energy use. So optimizing this process, and also utilizing the byproducts for other purposes. Like we know that like there will be a lot of byproducts produced by the food industry, and that byproducts can be used for other purpose, like and so that we can reduce the byproduct, the pollution generated by the byproducts, and also it helps the another industry. And the amount of food waste that is generated during food production can be minimized by this way, and that can contribute to a more sustainable food system. So I said that like by improving the extraction methods, we can implement the green green chemistry, right? So here, like there are a lot of green solvent extraction techniques have been used nowadays. For example, like pressurized solvent extraction, that is PSA, or microwave assisted extraction, so MAE, or ultrasound assisted extraction UAE, or aqueous two-phase extraction ATP. So by implementing these extraction techniques, we can reduce not only the use of chemicals, but also these techniques are more energy efficient compared to the other techniques we use in the processing industry. So it's like, as I told you, like these are all innovative techniques which exemplify the principles of green food processing, like high pressure processing, right? HPP. So here, this is not only reducing the energy efficiency and in maximizing the energy efficiency, it is also stands out for its ability to inactivate pathogens, because we know this microbial pathogens is an important factor in food preservation. So these methods, it is very good in to inactivate the pathogens and also extend the shelf life without relying on heat or chemical preservatives. So if we use this high pressure processing technologies, we don't need to add chemical preservatives for the food, because this is a basically it's a act as a preservative method also. And another technology is a pulse field electric field, that is PEF technology, that kills the bacteria and prevents the growth of pathogens and enhances the extraction of bioactive compounds using electrical pulses, and offering a sustainable approach to food processing. And nowadays, a lot of membrane separation techniques are using, especially in the fruit processing industry. For example, to make juice, and also they use here in most of the food industries in North America, they use employ this membrane separation techniques. So this purify and concentrate liquids while reducing water and energy consumption, and demonstrating the potential for resource efficient processing. And the method I told you earlier, that's the supercritical fluid extraction, which utilizes carbon dioxide under high pressure and temperature to extract valuable compounds from plants without resorting to harmful solvents, and furthering the cause of sustainable food production. So these are some of the food processing techniques nowadays used in different food industry. And also, green chemistry is promoting in sustainability by food waste reduction and valorization. So I told you that, like when we implement this green chemistry into the food processing industry, the food waste reduction will be there, right? So, and also the green chemistry emphasize on use of these byproducts that is generated from one food industry to the use in another food industry as a starting material, or uh, so that we can reduce the use of synthetic chemicals or synthetic starting materials. I have done some research on that, so I'll be showing that within few minutes. So this is the potential source of food waste and technologies for valorization. Like as I told you, the food waste that is generated from different industries and from agriculture, that is undervalued biomass, and that can be used for different production of different material, different compounds, like using different technologies. So this involves different stages actually. So when we use a food waste which is undervalued biomass, first there will be some pre-treatment process like a sorting, chipping, or grinding, etc. And then there will be like a processing stage by thermal conditioning, or using some catalyst or some solvents, or some enzymatic treatment. And then the stage two, that uses that mainly involves like the process how we are going to produce the compound which we are looking, like composting, hydrolysis, or fermentation, liquefaction, incineration, ADHTC, or gasification, etc. So this all process leads to development of different products in energy sector, and in like it can be used as a biocomposite, or in environment and or health, like producing different bioactive compounds or enzymes, etc., etc. So there is a huge applications on use of this food waste by valorization of these byproducts, which is generated from the agro and food processing industry. And a wide variety of chemicals can be produced by biotransformation of biomass and other from other platform chemicals. Like biotransformation means here mainly the technology they are using is fermentation technologies. So these fermentations can be done in three ways, like either in aerobic condition or anaerobic condition or micro aerobic condition. So it is between these two, aerobic and anaerobic stage. Okay, so here by this fermentation, by implementing this biotransformation technologies or microbial fermentation technologies, a wide variety of compounds can be produced. So here you can see like there are a lot of enzymes, and we know the production of biofuels, right, like ethanols, etc. That's it's a lot of research is going on that, and also compounds like esters or different type of acids, and even the hydrogen. Like we know now India is going to develop the different techniques to use hydrogen as a biofuel, right? So all these chemicals can be produced by utilizing the waste or biotransforming the biomass, which is generated from the food processing and agro industry. So now let's take some examples of this. I told you that like my research was mainly on the utilization of these food byproducts or from agro industry and food processing industry. So here's some of the research we have done, like the green synthesis of nanomaterials. So here we produced some nanoparticles from the bio-renewable sources, or like from the byproducts from the food processing industry. So here we have we developed a polyphenol formulation using a agricultural waste, mainly from the wine processing industry and the grape juice processing industry. So we know that it produces a lot of, during this processing, it produces a lot of grape pomace. And this grape pomace, we know that it's a byproduct and it's not used for anything else. It is just creating a lot of pollution, right? So this grape pomace is used for the production of used for the bioactive compounds, because we know grape is rich in antioxidants, especially like anthocyanins and polyphenols. So we try to develop a method to extract these polyphenols from the grape pomace, and then we developed a formulation which can like developed a method for the green synthesis of nanoparticles using these agro byproducts. Uh, this utilization of this agro products was done with the different byproducts, like so like green extraction and production of enzymes, for the production of enzymes and bioactive compounds from different agro and food processing byproducts, like mango and legume and apple. That is the byproducts from apple industry, and also from the byproducts from dairy industry. So the utilized green extraction of enzymes and bioactive compounds from the mango processing industry and legume processing industry was I did some research on this when I was doing my PhD in CFTRA Mysore. That's the Central Food Technological Research Institute. So we know that mango industry is one of the biggest industry in India, right? So there is a lot of applications in this mango industry utilizing this mango byproducts. And so here, by this method, I was able to utilize these byproducts as a source of polyphenols, antioxidants, and enzymes and dietary fibers from agricultural waste or agro byproducts. Okay. And also we did the microbial fermentation using this agro byproducts like apple pomace, and also the byproducts from the dairy industry, that is basically whey for the production of many microbial enzymes. And this enzyme has applications in bioremediation actually. So some of the enzymes we have produced by this microbial fermentation was used for the biodegradation or bioremediation of xenobiotics like a BPA, that is bisphenol A, which is a compound that is produced by the plastic pollution. You must have heard about that compound name, that's a BPA. So the enzymes produced by this microbial fermentation using this apple pomace and like the dairy byproducts, that was able to produce these enzymes, and which was utilized, which is later developed a enzyme formulation which was used in different industrial and environmental applications. So there are like many recent, sorry. Slide got this is stuck here. Okay, so let us see some of the recent projects that is making a mark in the food industry. That's mainly based on AI powered optimization systems. So here, this is we know that nowadays everywhere is AI, right? So this AI emerged as a powerful tools for minimizing waste and energy consumption in food processing. So recently, MIT they developed a food waste barrier. So in this, they try to reduce the food waste by optimizing the system by AI powered system. And also many projects are like is now going on by upcycling of food waste into valuable ingredients, the one I discussed now. So there are like a lot of plant-based coatings are produced from the these byproducts like mango peels and bananas, and which is like the biodegradable coatings which can used in the packaging industry. And also precision fermentation is another important area. Like there is a lot of research is going on in precision fermentation. That is a technique to create sustainable protein source from fungi and microbes using the food byproducts or agro byproducts. And also nowadays, like 3D printing for personalized nutrition, they are capable of creating customized food items that is tailored to individual dietary needs and preferences. So these are some this is an entrepreneur, they are working on this type of project actually. So these methods, like it helps to reduce the waste generation and also utilization of the waste that is generated by other food industry. So it's like a dentate approach, right? So we are using the waste and also we are reducing the waste. And there is also an important role in green chemistry in food and nutraceuticals. We know that nutraceuticals, like it's a important compound nowadays. Like everybody talk about nutraceuticals and antioxidants, etc. Right? So here, green chemistry is also have an important role in nutraceuticals. So this green chemistry allows us to create a wide range of sustainable food additives, including natural flavor enhancers, low calorie sweeteners, and plant-based emulsifiers. And also this, there are a lot of innovative bio-based ingredients for nutraceuticals. They are leveraging green chemistry principles to deliver health-promoting compounds that is derived from renewable resources. And also this green chemistry enables the development of eco-friendly packaging. As I told you, the biodegradable packaging developed from the agro byproducts that minimize waste, pollution, and resource depletion. And then green chemistry offers innovative solutions, including natural preservatives and energy efficient processing technologies to ensure food safety while maintaining its sustainability. Okay. So now let's see uh, the challenges and barriers that is we are facing in the food industry in terms of when we implement the green chemistry principles. First and foremost is scalability. Scalability. So here we know that green chemistry process may be expensive to scale up in large food production facilities. So when we do in the lab, okay, the principles will be working perfect. But when we go to the higher levels, like when we try to scale up that process, there are some like there is some variations what we are getting in the research lab and in the industrial level. So that is one of the challenges we are facing nowadays. And another thing is consumer acceptance. So that is shifting consumer perceptions from synthetic to natural additives and preservatives can be a challenge. But nowadays, by like a lot of consumer awareness program, we are like slowly slowly overcoming these challenges. Okay. And another thing is regulatory and industry standards. So lack of clear regulations and standards for green chemistry in food processing industry could delay widespread adoption. So this is one of the aspects we need to look into the future. So the future of green chemistry in food processing. So that's mainly emerging trends. So there are like a lot of research is going on in green chemistry and food processing, like increased focus on plant-based food products and sustainable processing methods. So now we know that there is a lot of plant-based food products are coming up, right? Like which can replace the animal origin foods like meat, or like even there are like milk they are trying to produce animal based, like the same cow milk what we get. So there are a lot of researches going on based on the precision fermentation, as I discussed earlier, and then innovations in smart packaging that interact with the food to maintain freshness without chemicals. So for this, implementing this green chemistry in food processing, there is a lot of collaboration is required across the sectors. So the future lies in collaboration between scientists, food technologies, and food industry to create innovative, sustainable practices that benefit both the environment and the consumers. So this is the future outlook of green chemistry principles in the economic system towards a sustainable development, which helps in the future. So as I told you, when we look on the future, we need to look on different aspects like, by reduced environment impact or resource efficiency or the process efficiency, and then international collaborations, health and well-being, and so we know that all this industry creates a job creation and economic growth, and also it has a great impact on climate change mitigation, and of course the innovation and the sustainable technologies. So in summary, I can say that green chemistry offers a sustainable solutions to mitigate the environmental impact of food processing, and it promotes human health and also drive economic benefits. While there are challenges, the potential for growth in green chemistry within food system is immense. So we know that we have seen that there is a lot of challenges when we implement this green chemistry in the food processing system, but still there is a lot of potential for growth in this growth. So we can work together for that, right? So the call to action, encouraging collaboration between industries, researchers, and policymakers to promote green chemistry in food processing for a healthier planet and future. So by this now, I'll stop here now. Thank you, and let me know if you have any questions.
Any questions, participant, please write on the chat box. One question, ma'am,
Okay.
on chat box. Why are government not banning PCC or other chemical colonic toilet soaps?
Sorry. Sorry, can you please repeat the last part? I'm sorry, I couldn't get it.
It's right in chat box. Why are government not banning PCC or other chemicals co-olefin toilet soap?
Okay.
They are known to harm environment but commonly found in soap.
Okay. Oh yeah. So as I told you, like there are a lot to improve in the regulatory aspects, right? Like because the thing is like even though we are using a lot of chemicals in the process, so this is soap is like different, right? That's a different chemical product, but they are using this chemical with a specific purpose. So we need to replace this chemical with something which is more related with the implemented with the green chemistry processing, right? So, and the main thing is that there is a lot to improve in our regulatory aspects, like that is all related with governments, their policies. So yeah, we need to get an alternative for this compound, and then we need to improve the or implement in the policies that like removing this type of chemicals. So once we have the alternative for this type of chemicals, then it is easy to remove it, right? So another question is, how can we overcome the limitation of green chemistry at large scale up? Oh yeah, so that is the one thing, the barriers, the or challenge we are facing now in terms of implementing this green chemistry in food processing industry. So here, when we do the research level, we will be like, we'll be satisfying all the things what we are looking, right, the objectives we are looking. But when we go to the larger scale up, there is a lot of changes. So the important thing is that what I felt from my research is we need to give importance for the optimization process. So we have to develop a optimization process for the technology, whatever we are doing, and then before it is transferring to the scale up process. So first, so it's better to follow a pattern that, like, first we do the research in bench level, then we go for a pilot scale, like pilot scale level, so that in pilot scale level we have more control on our process, so that in pilot scale we can develop the or optimize the process and then move to the scale up. So that way, implementing in this pattern, I think it helps more to reduce the uh, this scaling up, the challenges in the scaling up process. Okay, so I can see another question, or sodium benzoate in foods. What is that? Is it continuation of the first question, that banning about TCC?
It's
Yeah.
one more. Yes, it's related. No, it's related to
Okay. Yeah.
food. How can
Food.
we
Yeah.
overcome the limitation of green chemistry at large scale up?
Scale up. Yeah, that's what I was answering now. And I think the sodium benzoate is a
Sodium
continuation of the
benzoate.
first question about the regulatory that is commonly found in food. Maybe the first question, I think. Yeah, it is from the same person. Yeah, that
Yes,
is
yes,
a
same
one
person.
concern even. Yeah. That's the one concern even we also think about, that sodium benzoate. So from in my experience, I can say that, like, we were trying to develop some antioxidant compounds which can be used as a preservative in food, so that it can replace the sodium benzoate. So there is a lot of research, preliminary research is going on, and I think by near future we will be able to eliminate the sodium benzoate in food with a better green alternative. And what is the D is mostly from highly viscous solution. Does their viscosity also affect the extraction process? Yes, yeah, we know that, like, when the viscosity is an important factor, it's a determining factor in extraction process. So when we have like with the solutions with a very viscous, we need to consider that also. So what I feel that, like, if the solution is viscous, and is it a biological origin? So adding some enzymes, to which will be able to break up the compounds in the in the material. So that will help to reduce the viscosity and enhances the extraction process. So implementing, using some other green alternatives like enzymes in the extraction process, so that will, increase the efficiency of the process. The supercritical extraction using CO2 as a solvent, please extraction more lycopene from tomato. Yeah, I haven't, I don't know much about the from tomato, but the supercritical extraction is nowadays a lot of methods are used. Like there are a lot of protocols used for available for the extraction of lycopene from tomato using supercritical extraction method using CO2 solvent extractor. So there is a lot of uh, methods are available. If you want, I can share it. Like, if you can contact me later and I can share you some papers on that, some methods for that. How do we address the trade-off between environmental benefits and efficiency? Okay. Trade-offs between environmental benefits and efficiency. Yeah. So when you think in the terms of mm, green chemistry, we are not looking only one factor. As I told you, we follow the 12 principles in the green chemistry, right? So here, one of the thing is principles of green chemistry, of course, is environmental benefits. Like we try to minimize the pollution that is generated by the processing or any industry. And then also when we use more advanced technologies and as I discussed in the previous slides, we know that like if you use more green extraction methods or using different naturally compounds, we can increase the efficiency. So if you're adhering to the green principles, we don't have to trade off. We can achieve both environmental benefits and efficiency in that is why green chemistry is like a multi-dentate approach. So it has effects on all the aspects on that 12 principles. Okay. So if we implement green chemistry, I think we will be able to address both environmental benefits and efficiency. As a researcher in this who support this who promotes green chemistry, I feel that we don't have to trade off between these two. We can implement both of these, like environmental benefits and efficiency. So what is the state of art in the US on synthesis of phytochemicals which are found in Ayurvedic or herbal formulations like ashwagandha, etc.? Because we cannot grow so much by natural methods as continuation. Okay. So here the question is about phytochemicals. Oh yeah. So there is a lot of research is going on phytochemicals, and especially in North America. As you told, like because we know that Ayurveda is mainly in India, right? But there is lot of compounds like research is going on in the medicinal plants which is found in India that is commonly used in Ayurvedic. If you go to here in a in a pharmacy, you can see that lot of herbal formulations based on Ayurveda. Even I have seen some herbal formulations or phytochemical formulations or nutraceutical formulations which is from ashwagandha nowadays. There is a lot of consumer interest is gaining for this type of products actually, and a lot of research is also going in USA. And yeah, so the thing is that since the demand is increasing now, we need to look for the agriculture also, like we need to grow more, right? So I cannot understand. I didn't get what is meant by natural methods. Oh, natural methods of what? Is it the extracting the compound or growing the plant, ashwagandha? I'm not sure. I didn't get the natural methods, but as you told, this Ayurvedic medicinal plants is gaining interest in USA too. Like, and there is a lot of products available in the market now itself. Even I have seen now the turmeric, and even I saw some formulations that is developed based on moringa leaves. You know the moringa, right? The green leaf. So from that also nowadays there are like some nutraceutical formulations or health formulations are like available now in like even in the grocery actually. Apart from developing chemicals from agro waste, can we do research on engineering aspects? If and then, can you share the areas? Oh yeah, of course we can. Other than agro waste for the food import, food industry, food research, there is also a lot of aspects on engineering aspects like. There is a lot of fibers are developing, nano fibers, and are producing from the agro byproducts. So there is a lot of research is going on in that area. Like I have seen that nanofibers, and which has, we know the nanofibers have a lot of applications, right, in the engineering industry. So there is a lot of research is going on that too. Application in engineering side too. So sometime another question is sometime process that I hope I am answering all the questions. If you have any questions, any continuous question with that related questions, please ask me, okay? Because I'm just reading the chat actually. So I don't know if you have any follow-up questions with that.
Yeah,
Sometime
sure, sure.
process that, yeah, sometime process that are greener might not be the most energy efficient or cost effective. How do we find the right balance between sustainability and performance? Is it scalable aspect, as most of the green solvent require higher cost? Yeah, that is the in the last slide I was discussing about the challenges and barriers, right? So that is the one of the thing nowadays, the more the complicated, I should say, issue that is facing with the green chemistry research, that when we move to the scale up process, there is there is a lot of difference what we are getting in the lab and research lab and the scale up. So that is what we have to, the researchers, the scientists that need to, like you all, need to work more on that, because as you told you, like when it's but most green chemistry, like a green chemistry principle, if we implement properly, we can make it energy efficient. But at the same time, some process may not be that much cost effective. So we need to balance both this energy efficient and cost effective. So that is mainly happens when we go to the scalability level, right? So that is the one of the aspect we need to work more on that. Yeah. Okay. That's link sent. Okay, so that is something. We should percolate green chemistry at industry level by green chemistry audit or credit should be added, be like carbon credit or such type of measures should be in industry. Please give your comments. Oh yeah, of course, because we know that green chemistry is also adhered to the environment, right? So and especially there is a lot of research is going on carbon footprint nowadays, right? Like the carbon credit or the climate mitigation, etc. So with my research background, I can say that like this green chemistry has a very important role in in carbon credit or carbon mitigation, because as I told you, the one of the research team I was doing was utilizing the byproducts as a starting material for many of production of many compounds, right? So here we are reducing the carbon print by utilizing the waste byproducts, so that this is it has the waste, the food waste or food byproduct has a getting a differently new life, right? So it is not going into the pollution, into the environment directly. So in that way we are reducing the carbon. And also in another way, like for example, if I am using this mango peel or apple pomace for fermentation, right? So for fermentation, usually I need to have a medium or a synthetic growing medium to grow the microorganism. So since I'm not buying the synthetic medium, like which is again we are reducing the cost there, and instead of that synthetic medium, I'm using the byproduct which is obtained from this food processing industry. So there is a cost balance there, right? Like we are reducing the cost of buying the synthetic medium, because of course we know synthetic medium that is used for microbial growth or for the fermentation, sometimes we need liters of this thousands of liters of synthetic medium, but that same thing we can get from the byproduct, which is going to be a waste. So there is a balancing the carbon, right? Like we are reducing the carbon that is throwing into the environment. So that way it is like reducing the pollutants. At the same time we are reducing the use of synthetic chemicals. So that means we are reducing another chemical process there, right? So that way when we implement this green chemistry principles, we can do that carbon credits or a mitigation of carbon, etc. And also GHG emission also we can reduce it. Okay. Can we synthesize these compounds in a reactor instead of growing in the farm or forest? Of course, yeah, that's what I was telling you, the precision fermentation, right? So a lot of compounds are producing nowadays, like for example, like single cell protein or different compounds are produced by from the utilizing this microbial fermentation technique. So instead of growing in the farm or like in the forest, we can produce it like a lot of the compounds. So it is like, you know, agriculture in the lab, kind of like that. So most of the commercial units use hydro distillation for extraction. Is there any industry which is utilizing UAE, MANPA or any other green technology? Yeah, nowadays, like for most of the nutraceutical formulations and health formulations, these technologies are using. Like many nutraceutical industries in North America, they use these techniques for the production of formulations. Like for example, I told you that ashwagandha formulations, right? Nowadays it's available. So for that and all, they are using this type of technologies like ultrasonic or microwave assisted extraction, etc. While green chemistry aims to minimize waste, complete elimination might not be feasible. Yeah, you are right. How do we manage and recycle waste uh, created during green chemistry process? Okay, yeah. So here, yeah, the thing is that we cannot say, like, you remember the 12 principles of green chemistry. The second in that second principle was minimizing the waste, right? That atom efficiency I told you. So here in green chemistry, we try to minimize the waste, and also we are minimizing the waste, and also we are utilizing the waste from another product. So here, when we use the efficient technologies, we can convert the, according to the law of mass. You remember, like, cannot be the this like the way atom cannot be created or destroyed, it is converting from one conservation of energy, right? So the same way here, the green chemistry mainly looking to convert the whatever the starting material we have used for the process, that can be completely, or near to completion, we can completely converted into the product, so that the minimizing the waste maximum as much as we can possible. But we know that any process, we don't have that zero waste, right? Like technically we cannot make that, but the green chemistry, by implementing all these different technologies, we will be able to reduce the waste that is produced or generated by the process. And also, like as I told you, like if we are getting the waste from one process, that can be utilized for another process. So that way, like as you said, the recycling or utilizing the waste for another process help us to reduce the waste generation. Is language audible? I can't. Oh, can you hear me now?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes,
Okay.
ma'am.
If okay, yeah. I'm just reading the comments and answering. Okay. If you have any
Okay.
questions, please ask me meantime. If anyone want to talk or ask any question, okay, that's something. Okay. Uh, okay. I think, yeah, that's all the questions. Any more questions? Anything you can ask?
Any more
I can.
questions, participant, please?
Yeah.
Anyone want to
In
talk
future,
directly?
if you. Oh, yeah, sure.
Participant, anyone want to talk or ask any questions to experts? Please raise hand. We will allow them to talk directly. I think no.
All the questions
All
are
questions
answered.
maybe is over.
Oh, okay.
Dr. Pal, please
Uh,
go further.
Thank you very much, ma'am, for your informative, knowledgeable sessions to our participants. I hope all the participants will be explore knowledge in their research work and, as well as future work. Thank you very much, ma'am.
Okay. Thank you so much for the opportunity,
Uh,
and I really
Photograph.
like the way.
Ma'am,
One second, ma'am. Dear all participants, please switch on your cameras. We have to take one photograph. Hello.
hello.
Hello, dear all participants, please put on your camera.
Okay.
Okay. Now our next session will be start on 7:30 p.m. Please stay online, everyone. Thank you very much, ma'am, for
Okay.
giving your
Oh,
valuable
thank
time.
you very much. Okay. Yeah. Thank you so much for this opportunity. And yeah, I really thank Dr. Pal and Dr. Dumore, Nilesh Dumore, for all the help you have provided to me. And you are, as I told, like if you have any further questions, you can always reach me. You are almost most welcome to contact me. And yeah, so all the best
Yeah,
for your
sure,
program
ma'am.
and enjoy
Sure,
the rest
ma'am.
of the
Yeah,
day. Okay.
yeah,
Okay,
sure.
then bye
Thank you,
for
thank you.
now. Bye for now. I'm leaving now. Thanks so much.
Yeah, sure. Thank you.
Thank you.
Welcome.
Thank you.